to what it should be based on.
I guess the real question is going to be is why does it change? Is that a problem?
Now it will change if you're upgrading through this build, which I think is what's tripping up a lot of people right now. And I think that bug is fixed in build 102.
So you should preserve whatever your old host ID was instead of just generating some new random one.
So I think it's going to be that kind of thing. You know, you kind of wonder if they gave that job to the intern or something. You know what I mean? Somebody without a whole lot of experience in these things to have it jump up and bite. And I'm 99.9% sure that it's fixed in OpenSolaris 2008-11. Because again, when we're upgrading from 2008-05 to 2008-11, we'll have the same thing. And we know that path is going to be fairly well tested. So you're going to see some banter probably on the forum over the last week or two, people hitting the particular host ID issue with root. Yes?
So Spark immune?
Yes, Spark is largely immune because we'll get the host ID from the boot prompt. He said confidently. That was kind of funny because marketing came out to us and they said, hey, you know, we're talking about making the host ID be a file. What do you guys think? We think, well, it's about damn time because we've been spoofing it for 25 years. This will make it a lot easier. What? You know, and of course, my blog was a big hit on Google for a while. I tell you how to do it with me, right? So if you do Google on spoofing host IDs, then you'll find articles going way back about many ways to do that. But sort of fundamentally, if I have the kernel source code, then I can do whatever the hell I want. Right? So again, the ISVs were slightly chagrined, but they have to get over it.
Yeah, we just need a way to get the serial number off the PROM too.
Serial numbers.
On the older systems, the newer ones are okay.
I'm glad you think so.
Yeah, we still run a lot of old stuff, so it's still kind of frustrating. The new ones with ILOMs and system controllers, you can generally get it off of. I didn't know.
Yeah, the new ILOM machines, ILOM's getting a lot of our attention, so a lot of things that were long-term broken are getting fixed in ILOM.
Yeah, I still have a lot of 420s I work with, unfortunately.
Yeah. We track a lot of the data I see that comes in from the field. If you ever run Explorer, how many people have run Explorers? Yeah, a few. We have an Explorer database where all that comes in and gets thrown into a database, and the primary key is the host ID. And when they first started doing that, I said, host ID is not a good primary key. Oh, you're full of crap. Go away. Well, now they're really sad because they're supposed to be the primary key. And of course, it causes all sorts of interesting problems. But, well, what can I say?
The host ID plus some sort of other randomly generated host ID.
Yeah. But better yet, you make it look like a Spark machine. Just give it a host ID like a Spark machine would have, because they used to be the last few octets of the host ID were the same as your MAC address by default as well. So a lot of that goes way back to Motorola 68,000 days when we didn't have a whole lot of memory and that sort of stuff. Okay, enough of that topic. What time is it? It is 4:30. Somebody want to pick a topic or ask a question? We'll go from there.
I have a general question.
Yeah.
What's the biggest tool that you've seen that actually works? How many devices? Because I've read somewhere that it's recommended practice that you can only have around 10, 15 to make it work safely. But what, with the newest tampers and things like that, how do you manage? Do you create multiple pools, or what do you do?
So you'll find in the man page, when under the section on RAID Z or RAID Z2, we recommend that the number of devices in a RAID Z pool or a RAID Z2 set be like 3 to 9,
Yeah.
kind of a range. And part of the reason for that is that when Thumper first came out, people would say, I'm going to make a RAID Z, it's going to be 48 disk wide. Well, then they said, dear son, your performance really sucks. Right. So, what are you doing? Well, I made this RAID Z and it's 48 disk wide. It's like, oh gosh, no wonder, no chance you're going to get performance out of that, which is why this verbiage exists in the man page. Now, we came out, what should the number be? And it's like, well, we think 3 to 9.
That's for each pool?
For a set.
RAID plus standalone 1Z pools per month.
Okay, you have to ask the question again. So
Yeah,
I get it right.
I've got RAID plus standalone, it's like half terabyte to a terabyte, and have one file system on it. So do I want 1Z pool for that one?
In that case, yeah, I would probably do that.
Does the size of the devices matter?
Does the size of the devices matter? Depending on your pool configuration, it will. I need to draw pictures of this
Because
on my blog.
we've got a lot of our Oracle database servers have multiple terabytes, and they're in 36 gig LUN disks, and
Yeah.
obviously that's more than 10 devices in the pool.
Yeah. So okay. So in truth, you can have a lot of VDEVs, also a lot of top-level VDEVs in a pool. I haven't seen any real issue with that. We've done hundreds, like more than 500, right? To kind of give you an idea of in the lab testing. We don't tend to see that in the real field because you tend to run out of LUNs. or sanity. LUNs or sanity. You're going to run out one or the other sooner or later. We see a lot of Thumpers. We see a lot of Thumper, which has 48 disks. So we see a lot of spectrum on the Thumpers. For ray race things, it's a little different. Now, going back to Oracle for a moment, Oracle allows the data space to be 32 gigs in size, which used to be big.
Yeah.
And basically, they can't handle anything bigger than that, if I'm not mistaken, because I don't track them very closely today. But as far as I know, they don't allow a table space to be bigger than 32 gigs. So what we would frequently see is a DBA would come in and say, I need 150 32 gig volumes or LUNs, disks, however, whatever term of the day they use. And so that actually drove a lot of people, especially system administrators, to say, you ought to put that in a file system, and then it's just a file. So I'll give you a bunch of files that are that big, all in one file system, and Oracle will be happy, my life is good, don't bother me anymore. And that's kind of how it went. In my editorial comment, file systems cause Oracle a lot of grief in service. And the reason is that, how many file systems have you ever seen Oracle, right? So there's UFS, there's VXFS, NTFS, yeah, there's all UFS, there's all these, the Linux crowd has 6 or 7 file systems going on, right? So, and the thing is if there's any bug in the file system, that may affect an Oracle operation, then Oracle gets a service call, right? We'll blame whoever's name is on top, right?
Yes.
We call it in first, and so that costs them a lot of money. And so I think that's what drove them to build ASM. And you'll hear Oracle trying to push people to use ASM for Oracle. And so, at the same token, people ask us, well, why didn't you develop ZFS to be the perfect Oracle file system? And the answer is because Oracle's perfect file system is ASM from Oracle. We're not going to be able to do better than them. It's their application, right? And more importantly, ZFS runs on Solaris and Mac OS X. It doesn't run on Windows. It doesn't run on Linux. So why would Oracle constrain themselves to only using ZFS? It just makes no business sense, right? So what I try to tell people is that, okay, Oracle is very interested in you running things like ASM. They seem to work pretty well. DBAs may argue. It's not perfect. But I don't think you can expect ZFS to try to be a better Oracle file system than, Oracle is just not the design point for ZFS. So we know Oracle works in ZFS. We know some of the things that, we could make it work better. But in general, I don't think we're going to solve those things in software. How's that for a loaded question?
Well, our biggest challenge in that respect is we're possibly looking for ways to explore eliminating having to use ZFS and all the things associated with Symantec software, but also management of disks. I mean, most of our big servers are on format, and it's like 10 pages of disks, and you're trying to find it's just unmanageable. It really is.
So one of the ideas then is, okay, especially in the days of terabyte disks. So now I create a zpool, and I just can create volumes, right? Zvol, and create ZFS.
Yeah.
I can create a bunch of Zvols, give those to my DVAs, right? Don't bother me. You need more? Okay, I'll give you some more. So that's kind of the approach that I think a lot of system admins would like to take, specifically with the 32 gigabyte limit, which to a system admin today is small potatoes, right? I mean, you can't even buy a disk that small anymore, right? Except flash disk. But you can't buy magnetic disks that small anymore. So we have this tension, if you will, between the DBAs and the sysadmin people. I kind of led you down a teasing path about one of the reasons why I don't think we'll see a lot of ZFS effort into solving Oracle specific issues is that a lot of them have to do with disk latency. And disk latency is a problem for magnetic disks. That's not a problem for solid state disks. And so with the hybrid storage pool that we've started to talk about quite a bit recently, the hardware future says solid state disk is what you're going to use for performance. Right. And so you're going to use magnetic disks for cost per gigabyte, for cost per IOPS. Solid state disks are 100 times better than magnetic disks. And so a lot of the issues that we run into with Oracle in particular, or transactional databases in general, relate around performance. And so it's going to be easier, I think, for both sysadmins as well as vendors to just say, oh, you want performance? You buy this package. You want cheap storage per gigabyte, and you buy this package. That's just a specialization that's going to occur. And then the hybrid storage pool, you can kind of get the best of both worlds. Do you guys know when I'm talking about hybrid storage pool? I see a lot of blank stares.
Go over it again, please.
Hybrid storage pool.
Solid state and magnetic.
I didn't talk about the ZIL today at all, did I?
No.
Does anybody know what the ZIL is?
Some sort of automobile.
I've heard of it somewhere.
Okay. This is very important, and I'm really ashamed that I didn't add it into the list earlier. I'll try to do this without a picture, just because I don't have one I know handy. So I may have to, in our follow-up emails to you guys, I may have to draw pictures or point you to presentations with pictures. Okay. Back this morning, I was talking about the transactional nature of ZFS, right? So just like a database where we store things in log and then we commit this transaction, the commit interval by default is every 5 seconds. Okay, so one of the things you'll notice as a sysadmin, if you're watching IOStat and you put it like IOStat on the second boundary, right, which is always cool. So I'm doing IOStats, or maybe if you got a little performance meter that's watching your disk I/O, and things are coming in and being written, then every 5 seconds you're going to see the disk activity go up. And it may go up for half a second, depends on how much activity, how much RAM you got, and all that sort of rot. So that's the transaction interval. We're going to commit the writes to disk at that point in time. Okay? For most things, especially things that you might find lying about in your home directory, this works really well. So, I'm editing a store office file. I say save. If it stores it physically to disk in 5 seconds, I'm okay. Don't notice it. Happens in the background. No worries. However, there are things which we refer to as synchronous rights. It's sort of a misnomer because they're really blocking rights, but I'll use the terminology. You'll hear them called synchronous rights. FD sync, OD sync. You'll hear people banter about these terms. A synchronous write, what you want to have happen is, as soon as I tell you to write this, I want it on media permanently. Okay? Now, it turns out, when ZFS does that transaction commit, it does the same thing. So what ZFS is actually doing is it's saying, all right, flush all this data to disk, then we'll update the metadata and tell the storage device to make sure it's on permanent media. And when that completes, we'll say, okay, we're good. We move on to the next transaction. Databases work the same way. Okay, so now I have the issue that I have a database up here sending ZFS synchronized, write requests, and then ZFS can't wait 5 seconds to commit those. We have to commit them when the application asks for them. Now you're going to see this in 2 different places in particular. One is databases, like Oracle in a file system. The other is NFS servers. Okay, because when a client on NFS says, write this metadata, right, that is a synchronous operation back to the server. Right. So NFS is actually doing the same sort of thing. So when I run an NFS service on top of ZFS, then ZFS is going to be receiving from NFS synchronous write requests far more than you would ever expect looking at it from a client's perspective. Okay, so basically here's the thing then. So ZFS wants to be asynchronous and then do a flush every 5 seconds. But we have workloads that cause us to do a synchronous flush or write of that particular data immediately. So we created a log, and it's called the ZIL, the ZFS intent log. And what the intent log then does is, when these synchronous requests come in, it actually writes them to the disk, but it never intends to read them. Okay, so it becomes a write-only workload. Remember that. So it's a write-only workload. The only time we're going to read the ZIL is when we reboot after an interrupt. So if we crash, we reboot, we have to replay the ZIL, right, to catch up to the synchronous point in time because our transaction group didn't flush out. Okay, so we have this thing called the ZIL. And again, you'll notice it on things like Oracle. You'll notice it on NFS, particularly NFS metadata activity like tar -x, a bunch of little source files. It's usually where people complain the most. So you'll see this sort of activity. Now then, The ZIL writes into your pool. So if I have a RAID Z pool, there's going to be real data in there, and there's going to be mixed in these blocks of the ZIL. Now, in general, you could think of the ZIL as being 5 seconds worth of write data that hasn't yet been committed. Because once we do the transaction commit, all the ZIL data is no longer needed. So we can forget about it. Okay? And so this cycle continues. Now then, if you're using a JBOD system, which has a high write latency, by high write latency, 4 milliseconds and above, like a thumper, then you're going to notice certain workloads perform really slow, like tar -x on a bunch of small source files on an NFS client. Okay. So, with this knowledge, the engineers said, gee, how about if we take this ZIL write-only work and we put it someplace else? And that's called the slog. And so the slog? Slog? Separate log?
We already use that name for something else.
Okay.
That's why,
Okay.
so I had to make sure it's what you said.
So slog is a separate log. So basically what you can do then is you can take one device that, and this happens at the Z-pool level.
Great.
So when I do a Z-pool create, I can do a Z-pool create mirror blah 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 log blah. And I can set up a device to be the storage device for this log. Now, if you have just a regular disk, like a JBOD thumper disk, even if I use a regular magnetic disk, I get a performance increase because it's not also being used for my other data. So it's basically a write-only device. It's dedicated. It's pretty darn fast. So that's something to keep in mind if you're doing a lot of thumpers and you don't have a solid-state device. Okay, so now then,
How big would that have to be?
how big would it have to be? Great question. Our rule of thumb is as much data as you would expect to write in about 10 seconds.
Okay.
All right, megabytes.
Yeah.
We're not talking terabytes. We're talking megabytes, most likely.
Okay.
Right. So it doesn't have to be really huge, but it has to be fast. And so, in essence, this is what Oracle does by having a separate log. This is, this is all goodness. So, well trodden path here. So we do this separate log device that is available in Solaris 10 update 5. No, it's not. It came in 6. Separate log came in 6. Okay. Reason number 4,391. Why did I upgrade to Solaris 10 update 6? So we have a separate log device there. Now, for workloads like Oracle, when we put that on a solid state device, and again, it doesn't have to be generally a big device at all, we get much better performance. Now, if you're using a hardware RAID array with non-volatile write cache, it does the same thing. Okay, so we don't have complaints about this kind of performance from the RAID array guys. We have complaints about this kind of performance from JBOD people. Okay, because JBOD is where you have the high latency that's going to trip you up on this. Okay, so we have a separate log. So basically, it's a synchronous write log. We want to dedicate that to a hybrid storage and solid state device. Okay.
I've seen this problem with fiber attached attached solid sticks. Basically it. And the write cache got disabled, and it killed the NFS, absolutely dead.
Yeah. Performance will go
Exactly the same.
up the tubes. It is somewhat amazing to me that at first I was really shocked, but now I'm just tickled when this happens. I'll go into a customer and they'll have a performance problem. They'll say, performance sucks, blah, blah, blah. Let me see your array. Write cache is disabled because your battery is dead. Replace the battery. Life is good. I'm a hero. This is great. But again, most people are oriented towards performance. If the write cache is off, you'll notice it's bang. In ZFS serving NFS in particular, you'll notice it being quite painful. So that's a separate write log. Now, there's another thing. Oh wait, yeah, question?
So you're saying in the example with Thumper, if you just set aside one of those disks for the log, you probably would still see a performance increase. But under that scenario, would it just be one disk? It sounds like for this log, it wouldn't make sense to like mirror it to protect it or anything like that. Would just run with one disk.
So I recommend mirroring them. The jury is out on that to some extent. I'm not going to bore you with the gory details, but it's not a 100% win either way. Or it's not a 100% loss either way, depending on how you look at wins and losses. For really critical data, I recommend more data protection than not.
Okay, so data on that slog is registered as a committed write already.
That's correct.
The application. Okay, so it wouldn't make sense to mirror, even though it's quite a waste of space, but it's like you need the performance.
You know, what I recommend for Thumper users is a lot of people don't put anything on their root disks. So you have a 1 terabyte root disk and you're using 4 gigabytes. Hey, there's a good space to put a slog out there. I mean, you're not going to be really competing much with an OS disk because OS disks are forward most of the time anyway. But you want to avoid competing with your data disks. That's where the competition is. Because you're going to be competing, those slog writes are going to be competing with reads. And that's really where the rub comes. So I got a question over here in the stripes.
I didn't really hear if you answered the question about with Oracle. Like I had a customer one time that had many Oracle instances spread across hundreds of disks, like Veritas slices. And we would do migrations to new storage frames by standing up a set disk beside it and do massive STARs. And very time intensive and detail intensive. But I didn't see, when you answered that question, I didn't see whether that was a positive or negative in that sort of environment, if it was possible.
I think there's a couple of different ways to solve that. And I'm not sure that right now, I think I'll defer that to the bar.
Okay, what bar?
I think we'll go downstairs.
Right on, I'll see you there.
That's okay. But
Beer's on me.
Yeah. We may have done something like that similar where we had a mirrored Z pool on iSCSI or whatever, and we needed more space. So we bring in a new iSCSI log that's the size we want, and we break our mirror, so we're failed, and we do a replace on the one device to a new device which is bigger, and then we broke it twice. The first break was unintentional because there's a but then we use this situation to they're actually
break it and then put other breakers we saw back.
Yeah.
I know that mirroring is a good answer. We didn't do mirroring in this one because actually they were physical devices. We didn't have them under volume management. Now that I think about it. And we essentially, from the EMC guy, we got all the mappings of all the devices and we got and set them all up. But I didn't know if there was I mean, you had said something about on the large scale Oracle instances it wasn't a good idea to use ZFS. I thought I heard you say that. That's why I wanted to verify what it was.
I mean, this is surely my opinion. That is a lot of people will be happier using ASM, even if they hate ASM. For a lot of a variety of reasons, but particularly in the performance space, you want as low a code path as possible. And if you look at some submissions for benchmarks for Oracle, you'll see we do very large TPCH kinds of things, and we're using SM. Sort of my take is, again, we're not designing ZFS to do Oracle, but people are going to run in the file system anyway. And so it's something that we kind of have to live with now. As far as the relationship between the ZIL and the slog and Oracle workloads, it's very, very tangible. also tangible with ZFS workloads as well as others that I've mentioned and many of us have felt. So the same rules apply, the same solution applies in that case also. Yeah.
There's been cases, this is kind of a related question, there's been cases we found in the past where disks on our SAN were, well, our SAN is already striped, but we found out that in Volume Manager on the servers, they're striped again, so we have a plaid stripe. And the customer at this point isn't reporting any kind of a performance hit, so they did want to go through the migration to, non-locally striped disks. Is there any kind of a factor of ZFS that say that's good, that's bad, that's, doesn't really matter, or have any comments on that at all?
I don't have any comments. I'm not sure if anyone else has comments about plaids.
Stripping EMC disks.
That's a good question. That was before my time.
Yeah, we got things like that around.
Because I thought we were all concatenating.
Well, normally we do, but somebody, check that little box that's like striped. And
Yeah,
Oh,
it's like,
that's
what
right.
idiot did that?
Oh, yeah, glossary is the GUI.
Oh, that was me 3 years ago.
Yeah, so
We used to work there.
I mean, is that,
I don't think I have an opinion either way other than keep it simple. It's a good idea.
yeah, I mean, it's,
But I think it's fairly common. We'll see something like that happen. And I remember in ZFS there is no concatenation. You have a dynamic striper or not. So at the top level we're dynamic striping. Okay, one more question.
Yeah, just about the slog. Is it changeable or removable once it's set? I seem to remember reading somewhere that once you set it online, you can remove it.
It's not removable.
So you can't run an experiment to see whether a separate log will improve your performance. It's what you've done.
No. What you do for that experiment is you can disable the ZIL.
Well, that won't really have the same effect.
It's it will tell you if you're in the ballpark.
Okay.
And if you read the evil tuning guide, you'll see, basically it says, disable the ZIL, ? And the answer is don't. But again, for experimentation, I think we actually talk about for experimentation, decide, is this your problem? This is a good test to run. And basically, your risk is up to 5 seconds of data loss if I suffer an outage, an unexpected outage, while this experiment is going on. And typically that's a pretty safe bet, that I can disable it, see how it changes. If it doesn't, I re-enable it, and off I'm going. So that's an evil tuning guide.
The second question then was about the slug. Each file system has its own ZIL, right? The question is, do all of the ZILs go onto the same slug?
I believe all the slog is per pool.
Right.
So yeah, everything that would need a slog,
But the ZIL is per file system, right?
I believe that's correct.
So then if you have multiple file systems all running at the same time, will your ZILs then create tension on your slog plate?
No, because it's going to be scheduled and done sequentially. So all the writes to the slog really end up being sequential. And like I said, even for a magnetic disk, you're not going to be seeking. So kind of the worst effect you have is a rotational delay. Unless you do solid state, in which case you don't have rotational delay. Life is grand. Okay, so I think, if you will, we're taking care then of the right side of the hybrid storage pool. Now then, what about the read side? Because one of the things we did touch about earlier is if we have a bunch of sequential writes going on, and then we come in and we change some blocks, right, then they're copied on write. So now my sequential workload becomes a random workload when I go to read. Okay? And this is usually when the Oracle DBAs stand up and say, oh my God, when I go to back up my database, it's going to take 3 years. And because we're doing all these random seeks to read this data. And the answer is, well, yeah. In theory, this is exactly what will happen to you. So when we deal with these things, we have to also understand that there's a cache involved in main memory, and that cache is the adaptive replacement cache, or the ARC. And by default, the ARC will use as much memory as it can get its hands on. Sidebar, you can limit how much memory the ARC uses. Might be a good idea if you use things that use shared memory. Evil Tuning Guide talks about this. Okay. So I have this ARC that's going to be caching data. Now it's going to cache writes and reads, okay, which is very cool. So if I've got 128 gigabytes of memory on my machine, I'm going to be using a bunch of it for caching reads and writes. Yeah, it's a good use of my memory. So, I'm going to be a pretty happy camper generally. Now then, for really big databases, really large databases.
What's large?
Well, that's a good question. And this is a funny beer story. Even though I don't have a beer, maybe I'll talk about it. And that is, well, let me explain how the ARC works. And so it's an adaptive replacement cache, and it will vary in size in main memory. Well, if you know anything about caches, then you'll know that, well, if I have one cache, then one of the common tricks we see is to have a second level cache. Right? So in your processor, if you follow microprocessor design, right, first we had buffers, right? We had a little 3-byte buffer or whatever. And then we started getting like a 1K cache, and performance got better. And nowadays, modern microprocessors probably have 3 levels of cache. So there's a main cache, a level 2 cache, a level 3 cache. Every time you go up in that level, basically you're going to trade density for latency. Okay? So what do we do in ZFS? In ZFS, in Open Solaris did not make update 6. I'm very, very sure of this. We have a level 2 ARC. Okay. So how do we handle those random reads causing all those seeks? What we do is, in the hybrid storage pool, is we put in read-biased solid-state disks that are large, like 100 gigabyte kinds of disks. And you can have a bunch of these, of course. And then when we spill out of data in main memory, then we'll write that data efficiently to the level 2 ARC. So then when I go and do my table scans in Oracle, chances are likely that rather than having to go out to magnetic disk, do a seek and rotate, I can grab that out of the solid state disk that's read biased in the level 2 ARC. And that seek time is basically 0, or 200 microseconds versus 11 milliseconds, kind of a thing. Now then, so let's look back then at our slog. We want write biased because I have a write-only workload, and I don't need very big size. So I want kind of a smaller sized write biased solid state device. Then for my level 2 ARC, I want larger read biased solid state devices. And then back in the back, I want low cost SATA drives, kind of thing, to make that in the hybrid storage. So that's in fact the way we've designed this, and so we can have that hybridization of the storage. At the same time, we can deal with the reliability issues, because one of the things that you'll hear about bantered about in the solid state guys is that multi-level cell flash devices, MLC flashes, have a higher failure rate than, or higher memory loss rate, lower endurance than single level cells. But thanks, Jeff.
I'm actually really curious about everything else you have to tell us.
Right, so the idea, but then the density, the dollars per gigabyte is so much better on the multi-level cell devices. You guys want to know why? No, of course. Yes. So the number of bits I can store in a flash cell is based on the signal to noise ratio I can implement for reading the charge level. Okay? So what does that mean? So that means in one cell, I can have multiple bits stored. How many bits? Well, it depends on the signal to noise ratio. Okay, so from a practical perspective, there's an infinite number of bits I can store there. Well, from an impractical, theoretical perspective, there's a near infinite amount of bits I can store in that cell. From a practical perspective, the technology isn't quite there, and we have noise, so we have to deal with the noise. So that's how we suddenly saw a jump in the USB flash sticks in the past year. They went from basically 4 gigs to 16 gigs, 32 gigs really quickly, and the price really didn't go up much. I mean, it always goes up and then comes down, but in this cycle that happened very quickly. And the thing is that the price of a semiconductor is based on the area of the semiconductor. So the bigger the semiconductor, the more it costs. So if I can store more bits in the same space, right, then my density increases, my costs remain the same, life is good. Right? So what do we trade off? We trade off the endurance. Okay, fine. We have things like ZFS that can handle the endurance problem because we checksum everything, we do copy on write. Right? So I think you can kind of start to see some of these star alignments that are occurring here. So when we do a read biased solid state device, that's really what we're talking about. It's probably going to be MLC. It's probably going to be dollars per gigabyte less expensive than the write optimized or the write biased solid state device. But since I'm only going to read to it, I can handle it. Now, behind the cover, ZFS checksums everything that's read off. So what happens if I have a bit flip over here on the read biased level 2 ARC is I'll read it, the checksum won't match, I'll go back to main disk and pull the data. So it's just like a cache miss if I have a failure. So failures over here aren't that big a deal. Where we want to worry about our failures is on the slog. So on the slogs, we want to be biased to the writes, and most of those devices today are single level cell or yet another type of hybridization. They will be DRAM fronting flash. Okay, so if you go down to Fry's, you can go down to Fry's today and you can buy a solid state disk. Last time I was there, they were stocking Crucials. So you can buy a 32 gig solid state disk, $180 or something. And that device is made for the PC market and is sort of, I'll just say kind of generic. Neither write bias, or not what I would consider write or read bias. But the devices that are coming out for the enterprise space, and S-Tech is an excellent example of that. Our front appliance we're announcing today, we're fronting with S-Tech devices. They are expensive. They've got DRAM in the front end of that, right? So basically we're writing, across the wire, we're putting it in DRAM. In the event of a power outage, there's a supercapacitor or 2 or 3 on that disk that can keep the DRAM active long enough to destage it to flash. So we have flash on the back side there, DRAM on the front side. It's non-volatile, it's very fast to write. Okay, perfect slog device. So that's what we mean by hybrid storage pool and ZFS. We're going to have the ability then to create and mix and match optimized data storage devices based on dollars per gigabyte or dollars per write IOP or dollars per read IOP per gigabyte and so on and so forth. And you're going to see a lot of, I noticed there's a BOF, I think, Thursday night here for the solid state device guys, solid state disk guys are setting up a BOF at LISA. And hopefully they'll be giving us some good information about current trends and future trends in solid state disks for how that's all going to go. And maybe the last word I'll leave you with on that is Don't bet against Moore's Law. A lot of people try to bet against Moore's Law, and they tend to be roadkill.
It's not Moore's theorem, it's Moore's law.
It's a law. And basically what Moore's Law says is that every 18 months or so, I can put more stuff onto the same area. Okay. And since the cost of semiconductors is based on the area, it basically means for the same cost, I can deliver more stuff to you. And that's particularly true in the memory space. And that's how we ended up with 8 cores on a single chip, right? It's because of what Moore's Law says. And so, it's going to be an exciting time next few years. More cores, more memory, more solid state stuff. Things go faster, life will be good.
Maybe I'll put off my upgrade for my home PC for a year or so.
No, that's not good. You upgrade this
Never
year
works.
and next year.
Oh, right, okay.
That's how my wife's
I'll just get a Sun Ultra 20 and be done with it.
Sun Ultra 20.
Got one.
Yeah.
Yeah.
Do we sell those still?
Used to.
Got one on my desk.
Spark?
Oh, no, it's x86.
Okay, that's A6 one.
Oh, I see.
Yeah,
The Ultra 30 or Ultra 60.
No, it's a couple of years old.
Yeah.
the Spark workstations are no more, is my
Yeah, yeah.
I have an old Blade 150 sitting under my
Yeah,
desk.
I haven't seen the new Spark
But
workstation.
it makes a good footstool.
It works pretty much.
I took a VCS class that had Spark laptops. Those things were
Yeah,
old.
about the lowest you
And only
can
half
get
of
is
them
about
worked.
5120.
Like $15,000 a piece. Yeah.
Well, that was because of the LCD though. I'm serious.
Really?
Yeah. Back then, when I was working with RDI, which was competing with Apple, yeah, go for that. Which back then a 640 by 480 color display, $5,000 just by itself.
Wow. But the laptop cost $49.95, right?
Well, they were making a profit. By the way, 64 gigabytes, $160.
64 gigs, $160. Yeah. So there's this price dynamic in the semiconductor business that really, for systems guys, it works to your advantage. And I think today, if you get a chance, a lot of the benchmarks we've been running related to the appliance launch today, the 7000 series launch, we do use the hybrid storage pools. So you'll see some pretty staggering numbers, I think, because of how all this stuff works together. We're actually very, very excited about it. And we think, it's going to really change the price point for some of these high performance things. Having said that, when they don't ask me about pricing, and I have an MBA, and I will tell you that they don't want to ask me about pricing because I would be terrible at it. It's black magic. There's
It's a guess.
It's a swag.
all
It's
estimates.
it's something that I've proven to my marketing professors that is not something that's my core competency. That's my grades reflection. So, I can't tell about pricing and how all that will go. But I think the old days of large amounts of DRAM backed things with batteries are numbered. Shall we say that? All right. We're winding down a little bit. I'll be happy to stick around, but I got to take a break for a few minutes. Do you guys want to hang out, or want to go to the retire to the bar, or any proposals? A couple of questions. Okay. How about if we do this? We'll take a break for 5 minutes or so, and whoever remains will answer questions for a while, and then when I start getting low, we'll go downstairs.